of course, we have the statements and we have conclusions. Normal approach, we'll go for Venn diagram first. All phones are smart. All phones are smart. Second one, some smart or expensive. What we need is some smart or expensive. So there is an intersection between smart and expensive. So some smart or expensive. Now look at the conclusion. Some expensive are phones. Some expensive are phones. Is it? I don't see any intersection between expensive and phone. So this is invalid for the basic diagram. So positive conclusion, invalid for the basic diagram. It doesn't follow. And how about conclusion number 2? Some phones are not expensive. Some phones are not expensive. If you take some phones from here, they are not expensive. Actually, that is valid for the basic diagram. It's valid for the basic diagram. However, every time you remember this, a positive conclusion, if it is valid for the basic diagram, it follows, no issues. But this case, it's a negative conclusion. See that? Negative. Some not statement. So if it is some not, and if it is valid for the basic diagram, this is the basic diagram, if it is valid for the basic diagram, then you have to recheck it. From the exam point of view, this is what you need to understand. Every time you get a negative statement which is valid for the basic diagram, what you have to do? Negate the statement. Negate it. So what is it? Negate. How do you negate it? It must be negated. I'll just write it over here. Negate. So this is a negative statement. When you negate it, negative is negated, it will become positive. And what would be the negative of some not? You may think it would be some, but in logical deductions, that is not the case. The negation of some not would be all. That means all phones are expensive. So negation would be all. All phones are expensive. Once you have the negated statement, the next thing what you have to do is draw a new diagram. This is the basic diagram, and what we are going, this is, I'll just write it over here. This is a basic diagram, and we need to draw a new diagram using this negated conclusion. So how do we do it? All phones are expensive. I'll draw that diagram. All phones are expensive. Now, in this diagram, new diagram, we have phones and we have expensive. What it is missing? That is smart. Now, you have to check the connection between smart and phones and smart and expensive as well, because we need to bring that smart into this diagram in order to make this diagram complete. Actually, in the beginning, from the statement, we know that we have 3 terms. Right now, we have only 2 terms when you draw the Venn diagram of all phones are expensive. That means we need smart as well. So look at smart. Smart is connected with expensive, and phones are connected with smart as well. So smart has a connection with expensive and phones as well. What is this? What is the connection? All phones are smart and some smart are expensive. So that same connection we need to bring it over here. So what we need is all phones are smart. So we'll draw it here. All phones must be smart. I'll just draw like this. All phones. The phones must be inside smart. So all phones are smart. At the same time, what is the other thing? The smart is intersecting with expensive. So when you draw it like this, the smart, this part of smart is intersecting with expensive as well. So that diagram, the new diagram is complete. We have all the terms. All the terms means phone, smart, smart, expensive. Phone, smart, expensive. All 3 terms here. Now we need to check the existence of this new diagram. Actually, this new diagram is based on the negated conclusion. But if the diagram exists, that must be following or that must be valid for the given statements. So we'll need to check whether this new diagram exists or not. Let's check it with the statements, original statements. So all phones are smart. Yes, all phones are smart. Some smart are expensive, some smart are expensive. That means whatever given in the statements, that is true for the new diagram. So new diagram exists. The new diagram exists. New diagram is drawn based on what? On the negated conclusion. So if the new diagram exists means negated conclusion is valid. So negated conclusion valid. And if negated conclusion is valid and the original conclusion would be negative of it. This case, negated conclusion is positive, so original conclusion is negative. If the negated conclusion is valid, then the original conclusion would be invalid for this diagram. For the basic diagram, we got it valid, but for this diagram, it is going to be invalid. That means if you have a conclusion, it is valid in one diagram, basic diagram it is valid, and it is not valid in other diagram, then it cannot really follow the statement. The reason for that, if the conclusion follow the statement means it must be valid for all possible diagrams. So this case, you have the negative conclusion which is valid for the basic diagram. So we negated it and we have drawn a new diagram. That new diagram exists. That means negated conclusion is valid. If negated conclusion is valid, original conclusion is negative of it. So if this is valid, yeah, original conclusion must be invalid. So this is invalid for which diagram? Invalid for the new diagram, right? And ultimately, this particular conclusion is valid for one diagram and is invalid for one diagram. So ultimately, it doesn't follow. That would be the answer. And this one doesn't follow as well. So for this particular question, the conclusion 1 doesn't follow, conclusion 2 doesn't follow. So the answer choice would be, you have to look at the direction. Sometimes the direction, it would be given that mark your answer as D or mark your answer as E if neither conclusion 1 nor conclusion 2 follows the statement. So for this question, the answer is both conclusions do not follow, or neither 1 nor 2 follows the argument.